And first, I learned it not right way, and was called photography hashes. So I said, okay, fine, but this does not look like photography. And I asked her, no, I was mistaken. It's cryptography hashes. Now it should be integrated. Please welcome Beth here.
So, I am not a cryptography guru. I don't group in that space. I don't even follow it that much. But I needed to study it as part of my goal to get a CISSP. So 4 years ago, I started that, and I was pulling out my hair about cryptography. And there are so many aspects of cryptography. And so you start to grab onto a portion that you kind of like a little bit better than the other. So I did get a greater appreciation for this, and I have to marvel at the minds that create these algorithms. So they take this data, and they mash it up in a way so that it's confidential. It can ensure integrity to make sure the file hasn't been modified, and it can make sure that you were the one that sent it and not someone else. It's just amazing. So of the hashes, but of the types of cryptography that I like the most, I really like hashes. And so I want to talk about that and give you a little bit more visual impact as to what a hash is, because there's so much to cryptography. So this cartoon, I thought, kind of sums it up best. The hashes really take on different inputs. They work their magic, and then the output comes out the same space, but everything is unique. It's a very interesting type of hash, and what I like most, or where you see it most, is with digital signatures, file integrity, and the one that I like the best is password storage. Because people come to me and ask, I forgot my password, can you go look it up? No. I'm thankful to say no. The auditors are happy that I can say no, because it's actually stored as a hash. So if you look at it, it looks like all garbage. But what I found interesting as I was studying hashes a bit more is to find out some fun facts about them and just how they kind of work. And I'm going to show you an example of what a password hash would entail, to kind of give that visual impact. So that if you decide to pursue a CISSP, there will be questions about cryptography. And there most likely will be a question about hash. And maybe, just maybe, the visual imagery that I can show you here will help you do that. So let's get into a demonstration of let's talk about what makes a good hash. So the inputs can all be variable types, but they all are used. And we'll see that a little bit more with the demonstration. Now the output is designed to make it unrecognizable. So again, when you're looking at it, it just looks like it's perfect. And that no two results are the same. This is very important for hash functions. And then last, the size of the output space really does matter, and you'll see why and why we keep having to get better about that space later on. So I want to show you an example. Again, I grew on identity and access management. That's where I like. So when we talk about password management, I'm like, oh, okay, I'm kind of interested in this. And so I learned a little bit more about how Active Directory stores their Kerberos passwords. So I wanted to kind of give you that visual so that you can kind of understand those different parts. So I'm going to show you the best analogy that someone had told me about hashes was it was like breaking glass. And I didn't want to break glass. So I made some ice. But I wanted to show you what this would be. So imagine, what's the first thing you do when you go to your computer? What's the information that you provide?
Use my password.
Correct. So let's say we have here, we have your username. Red. Vince, you're red. This is your username. And then this is your password. Blue. Blue is your password. And then the magic of with Microsoft and the Kerberos hashes, there's a constant number. So this is a constant that with every password combination is going to have this combination. So we put this all together, right? So I'm using all the parts. And then the hashes, break it up. So they break it up into all these little pieces, making it unrecognizable. So we'll say that it even melted. So there's no part. You can't see the different parts. this is what a hash would be. So the other fun part I mentioned about that no two are the same. So we have two different ones. So let's imagine, again, I'm going to just drill this idea into your head. So again, so maybe next up we have Laura. Laura's just going to log in. You're yellow.
Mm-hmm.
Let's say by chance you two were both on the same mindset and you have the same password. Same password. And you're in the same environment, so you have the same number. You have the same Kerberos number. You put it in there. You say submit. And then you come out and you look at this. So when you go to log in, though, the main thing is that this is a poor example here, but going back to Vince, that the two, so when he logs in, these two are going to match. This just needs to be up. So it's a little bit more of a visual aid to kind of say how those work. Now the other piece to understand about hashes, and another way to do some visual imagery, is that oftentimes we say that the password is encrypted. Well, technically that's not true with a hash. It's called a digest. And this is where, again, another visual imagery of what you can think of a hash. Because just like when we digest food, food goes in, and no matter how it comes out, it's not looking the same. So again, another way to visually have that imagery around hashes. Now the last thing that I wanted to say is that all good hashes come to an end. Because the problem that happens is there's hackers out there, there's people that are looking for those patterns. So given enough time and computation power, they'd be able to see the different components in here. Because it's a small space. So if we take and we look at a bigger space, like let's say if we were looking for a message with grains of sand, and this is all full of sand, right? It's going to take you longer to figure out that little message in here. But then imagine that you've even got even more space. It's going to take you even longer to figure out that message. So the space does matter, and the longer than the space of that output, the better off you are. And the last slide that I wanted to share with you, although it's got a lot of numbers, the main thing to show is that there's different types of hashes, and what's interesting here is this is a timeline. So back in the day, this MD4, 1990, it was grooving, it was awesome, but then it was broken. And you can see here as the progression of time, we're getting stronger computation power, and we're able to find those patterns in hashes. So as brilliant as people are that create this, there are also brilliant people out there that are trying to break those hashes. So we can see as we move forward and through time, we need to continue to evolve this artistry and be able to come up with more computation power, to give more space. So I just want to leave you with a few points to remember about hashes. As I mentioned before, they're digests, it's not encryption. A good hash function will use all the parts. It will make the parts unrecognizable. You can think of that breaking glass. And then no two are the same, and you want that output space to be as large as possible. So if you decide to pursue a CISSP, I would be happy to talk to you and give you some tips and tricks. It was a massive studying amount, but I was glad to get it. And if you don't, then at least maybe I left you with an imagery, like when the next time you log in, you'll think of that crashing down.